So hello student friends, in the last lecture we had seen the standard SOP equation from or for a given truth table. In this lecture let us see standard POS expression for a given truth table. So we can consider the same truth table. Okay, and we can just refer the steps again. Now the steps are quite similar. Just instead of the SOP we had gone for 1, here POS corresponds to 0. Now we have to look for those entries in the truth table which has output 0. Okay, so let's go through these steps. Consider only those combination of inputs in the truth table that produce or has a low output, y equal to 0. Now we have to search for those combinations where y is equal to 0. Write the max terms only for such input combinations. Okay, so you have to just write the max term only where y equal to 0. Now here ANDing operation is required, because if you see the form of POS, it is this form and this is ANDing form. Okay, use ANDing operation for these max terms to obtain expression in standard POS form. Okay, so again let's look at the same. We have taken, this is XOR, truth table of XOR gate. Now here you have to see this entry 0. So we can say this is y1 and this is y2. So y equal to y1 dot y2. Okay, now can I write my y1 equal to, now for POS 0 means that variable and 1 means variable complement. Okay, so here it is 0, so this becomes A plus B. Since this is product of sum, okay, product of sum, that is why it is A plus B. And my y2 is A bar plus B bar, right? So y equals to A plus B, A bar plus B bar. Okay, so this is the POS, standard POS equation from given truth table. Right? So quite easy it is. Okay, now let me elaborate these concepts further. Now here you may say that since this is XOR gate, the equation for XOR gate is always A B bar plus A bar B. Then this and this equation seems to be different. And how can we consider that this equation is for XOR gate? Okay, here we can prove equivalence, pardon me for this spelling, equivalence of SOP and POS. Okay, so as I said, generally we go for SOP, but SOP and POS, they are same. Now how to prove that? Let us consider this equation itself. So I have y equal to A plus B, A bar plus B bar. Now let's try to simplify this. Let's simplify this. Okay, now using our Boolean algebra laws, laws, so y equal to A into A bar plus A B bar, right? Then B into A bar is plus B into A bar, means I can write A bar B plus B B bar. Now according to ANDing laws, A dot A bar is 0. Okay, A dot A bar is 0. Similarly, B dot B bar is also 0. The variable ANDed with its own complement will result into 0, right? So, can you see this term and this term becomes 0. So, y equal to 0, this is 0, so no need to write that, it becomes A B bar plus A bar B. Is this the equation for XOR gate? It is, right? So see, I took POS and then I verified with SOP. So they are same. Okay, so that is again quite easy. So this is how you can form the this standard POS expression from given truth table, where you have to look for the output entries having 0 value or that produces low output, and you have to check its input combinations. Okay, so I have one example for you. You can just try to solve this. Okay, let's take it randomly. So this is can say 0 1 2 3 4 5 6 7, considering 3 input, because we have A B C, 3 input, right? So this 0 is 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Now consider that this truth table is the truth table of some arbitrary random circuit. किसी एक सर्किट का ये ट्रूथ टेबल है और उसके लिए हमें इक्वेशन फॉर्म करना है. ओके, एंड द आउटपुट एंट्रीज आर 0 1 0 1 0 1 0 1. Now the question is form the standard SOP and POS expression for given this truth table. And let me know that you have actually formed the correct this expression for the given truth table, right? And you can extend this exercise, and for this truth table, prove the equivalence of SOP and POS, right? So you have to consider that process. Take POS expression, solve them and verify with SOP. This is what you can do. Okay, so in the last lecture I said that we can prove the equivalence of SOP and POS, though we generally go for SOP unless until specified. Okay, So I hope these concepts are clear for you, right? So this is all for this lecture. Thank you and have a nice time.